For the next example, we're going to do a very similar problem. The only difference is that we are going to take our original function of f of x is equal to x squared, and we are going to translate it 3 units to the right. So I already have the table of values that we found above for our parent function. Remember, our parent function is a function before we've added any transformations. So I'm going to pause and I'm going to graph the parent function. One, two, three. Okay, and now let's look at our domain and range. For g of x, so the domain, so notice because we changed and shifted this to the right, well, right and left have to do with our x values, and our x values have to do with domain. So notice that our domain has changed this time. Our lowest value is 1, and our highest value is, let's see, 1, 2, 3, 4, 5. 5. So let's look at our original domain. We had -2, and that makes sense. We added 3 to it, so it's now become 1 as our minimum. And our maximum domain was 2, and we added 3 to it, and now it's 5. And what do we notice about the range? Well, we didn't change this by translating it up or down at all. So that means our range has remained the same. It is 0, 4. Now let's talk about the actual equation. So this one's a little bit more tricky. When we shift things left and right, or if we do any changes to the x-axis, notice that they happen inside of our function. And what's really weird is anything that happens inside of our functions, and by inside I mean inside the parentheses with the f on the outside, it means that it's always the opposite to what we think it is. Very confusing. So let me show you what the actual equation is. So g of x is equal to x minus 3 squared. Now you might be looking at that saying like, what is she talking about? Because we added 3 to the actual graph, correct? Let's do a test point. So our graph is above, and let's test our vertex right here. So our vertex is 1, 2, 3, and it should be 0 if we plug it in to our equation. So I'm just going to do the test point 3, and I'm going to plug it into this equation to see if we get 0. So 3 minus 3 squared, okay, that works, equals 0. Let's try another point. So let's see if it works for 4, 1. So if I say my x value is 4 and I plug it into the equation, so again, plugging it into this equation, so we're going to plug 4 in for x minus 3 squared is equal to 1. Oh, there's our coordinate, 4, 1. So let me recap. In the first video, when we're shifting up and down, we add or subtract the numbers after our parent function. We shifted down by 3, so we actually put a -3. When we're changing and going left and right, then we put our number inside of the function, and don't worry, I'll talk about this more in class, and it's always the opposite. So because we moved right by 3 units, we're actually putting a -3 into our equation. So in general, g of x, so that's our new function, is our original function where we're adding or subtracting a number to the x inside the parentheses. And we call this a horizontal translation.